All right, 210 is called inverses of exponential functions, okay? So we bring in back like logs, exponential, and inverses in this section. So first of all, exponential graph would look like the one on the left-hand side. That f of x equals 3 to the x would be an exponential graph. And then on the right-hand side, we've got a log graph. So for today, we're going to talk more about the relationship between these two. And then in the next section, we'll get more specific on just log graphs. We'll talk about like domain and asymptotes and all that kind of stuff. So if we're just comparing these two, notice the inputs and the outputs on these guys. So like if I were to pick a point here, this would be 0, 1. This would be 1, 3. And on the right-hand side, this would be 1, 0, and this would be 3, 1. So if I were to compare the inputs and outputs of these, what's the relationship between these two? They switch, right? The x and the y switch on both. And what kind of relationship causes that? An inverse, right? The inverse, we switch the x and the y. So if it is just the like simple, we're not talking about with any translations or anything like that. If we're talking about our simple exponential function where 3 is the base and then we compare it to a simple log function in which 3 is the base, these are inverses of each other. The inputs of one become the outputs of the other and vice versa. The domain of my exponential function, so if I ask for the domain of the one on the left, you would tell me it's what? All real numbers, right? This arrow points this way and this way. Negative infinity to positive infinity. What's the range of that exponential function? 0 to infinity. Can it include 0? No, there's a horizontal asymptote there, right? So 0 to positive infinity. Now, what do we think is going to happen on our graph on the right? They're going to be switched, right? So this arrow points down and this arrow points to the right, but also up. It would keep getting bigger, which means the range on this is all real numbers. And there's a vertical asymptote at 0, which means the domain is 0 to positive infinity. So true to form on inverses, our x and y switch, which means our domain and range switch. And on the exponential function, you have a horizontal asymptote at y equals 0. And on the log function, we have a vertical asymptote at x equals 0. So because these are inverses of each other, all those behaviors literally switch. So in an exponential function, as inputs increase additively, so we're looking at the important terms here, as inputs, and they could increase or decrease, but as they change additively, the outputs are increasing or decreasing. Again, it could change, but multiplicatively. Meaning if I add something on the left-hand side, on the right-hand side, or on this chart, on the right-hand side, my outputs are being multiplied by the same thing each time. So if I just look at like 3 to the x, if I use, let's do 0, 1, 2. 3 to the 0 is 1, 3 to the 1 is 3, and 3 to the second is 9. If I go one more, it's 27. So as my input values increase at a rate that is additive, meaning I add the same thing each time, my outputs are changing multiplicatively, meaning I'm multiplying by the same thing each time. So here we're adding 1, and here we're multiplying by 3. On the log function, so if I did the same thing, well, that's a bad example, but I'll get to it in a second. If I do 0, like log base 3 of 0, is that possible? No, so this one's not possible, but log base 3 of 1, what's that? That's 0. I'm going to skip over 2. Log base 3 of 3, that's what? 1. So this time we're increasing, we're on the right, you're adding 1, and on the left, you're multiplying by 3. So we'd switch it. So if you were just given data and you see the input changing additively and the output changing multiplicatively, then we're going to classify it as exponential. If we say the output changing additively and the input multiplicatively, now it's a log. Because you can't find log base 0 of anything. Like, that's impossible. 2, it's just that it would be a decimal. We wouldn't be able to find it without the calculator. Yeah. So think back to, here's a chart. Determine if, now our options can be linear, they could be exponential, they could be quadratic, they could be cubic, and they could be logs. So if it's linear, it's the first difference, quadratic, second difference, cubic, third difference, exponential, you're multiplying by the same thing each time to get your output, and log, the input, you'd be multiplying by the same thing each time. All right, so example 1 says describe the function as exponential or log and then find the points for its inverse. So the first thing I'm going to do is figure out the relationship. Looking at 1, compare your inputs and your outputs. What's happening? The inputs are being multiplied. The outputs are increasing additively. Yes? So what kind of function is this? This is a log. To find the inverse, we just switch it. 0, 1, 1, 3, 2, 9. 327. So that would tell you what kind of function is the output. Is the inverse. Exponential. Good. All right, go to 2. What's the relationship on my initial function? Inputs are increasing additively. Yes. What's happening to the outputs? Being multiplied by 5 each time. So the initial is what? Exponential. And the output, which I'm going to switch, or not the output, sorry, the inverse. I'm just going to switch these, would be log. Good.
Is the inverse of the log exponential?
Yep. We still good? Okay. All right, now we're going to determine if f of x and g of x are inverses of each other. Do you remember how to check to see if something is the inverse? We did it last week. One gets plugged into the other, so f of g of x and g of f of x, and what do we expect to see on the outcome? Just x. So in order to show it or prove it, we're going to do f of g of x, and then we're going to do g of f of x. And both should result in just x. So for the first one, I'm taking this and I'm plugging it into the exponent. So 2 to the 3 times log base 2 of x divided by 3. What happens to the multiplying by 3 and the divided by 3? Cancels, and I get 2 log base 2 of x. And when the base in your exponential function is the same on the base on the log in its exponent, they cancel out, and what's left to that log, what's left on that log would be your answer. So if the base on the exponential function is being raised to a log that has the same base, we cancel it out.
Do you have to do like
Yes. Yep. If I'm just using this to check and see if my answer's right, and I don't have time to do both, obviously you don't have to. But if it's saying to show it, you got to do both. Okay, so g of f of x, now I'm reversing it. This is getting plugged in to the log. So 3 times log base 2 of 2 to the x over 3. What can get simplified? Log base 2 of 2 to the x over 3. The log base 2 of 2 cancels and leaves you with the exponent. So this becomes 3 times x over 3. And then the 3's cancel, and I just get x.
It's not an exponent anymore?
No, as soon as you do, so log, base, anything, so a to the a, whatever's on the exponent here becomes your entire statement. The rest of it's gone. Questions so far? So as we go through today, we're reviewing a lot of properties of solving logs, which is obviously going to be important moving forward. So if there's something that you want to ask a question on, ask it. All right, so this was a yes. Okay, so now B, same thing, f of g of x, and then g of f of x. So this comes into the exponent here. 2 to the 3 times log base 2 of x. So this becomes 2, and you can do this multiple ways, but this would be 9 times log base 2 of x. Does this cancel with this? Trick question, kind of. If you remember your properties of logs, which we haven't got to yet, which is why it's just weird these kinds of questions come up in this section, but they do. If you remember your properties of logs, if you have something being multiplied on the front and you wanted to condense it, you kick it back to the exponent. Does this sound familiar? So if you have a product and it's something being multiplied on the front, we're going to review this again in 2 sections. But if you had it on the front, it would get kicked back. So this would become 2 log base 2 of x to the 9th.
Oh, yeah.
Now I could cancel this, right? But it's still x to the 9th. Is that x? No. So I don't even have to go through the work of finding the next one. If it doesn't simplify to give you x, it's not the inverse. But also, if I had done the second one, if one of them is wrong, the answer is no. Questions on that one?
So we wouldn't have to do the...
You wouldn't have to do the other one because you already know it's no. Don't waste your time. So now it says find the inverse of the function. So we're going to review some rules on, because again, we haven't done a lot of the solving of logs yet, okay? We're going to review some rules on how to get to exponents and how to get from logs, okay? This is just inverse. So if I want to find the inverse, what's step 1? Good, then switch it. X equals 2 to the y. Okay. Now to get to the exponent, I have to get rid of the exponential function. The opposite of an exponential function is a what function? Not log, opposite, but inverse is log, right? So if you remember this from Algebra 2, you would have had a calculator, and we would have typically LN'd both sides of the equation. Do you remember when we made it a verb? Okay. The difference is I don't have a calculator this time. I can log both sides of the equation of any log. So what I'm going to do is I'm going to pick the log that has the same base as my exponential function so I can get to that y. So I'm going to log base 2 both sides of this equation. Because what happens to log base 2 of 2 to the y? This cancels and leaves me just with y. So you want to log the base of the one you got to get to its exponent. And then the very last thing we're not going to forget to do, because it would make it wrong, right, is change that back to f negative 1 of x. Okay, go to B. Step 1, make it a y. Step 2, switch the x and the y. So x equals 4 times log base 3 of y. Now eventually I have to isolate that y, right? Which means I want to get rid of the log. What do we do to get rid of a log? Convert to exponential, right? But I can't get to that. I can't do this until the 4 is gone. The log has to be by itself. Divide by 4. So x over 4, or 1/4 x, because that's the same, equals log base 3 of y. And now the 3 is going to pick it up. So 3 to the x over 4 equals y. And then I'm going to make that, this is now g, right? G negative 1 of x equals 3 to the x over 4. Which again could be 1/4 x. Both of those would be right. Because eventually we're going to go back to talking about how does that translate, right? What would that cause? That would be a horizontal dilation.
Could you also just do 3 to the power of the 4th power of 3 to the power of the x? I guess the quartic power.
4 as a base?
No. The 4.
All right, last slide. Same set of instructions. Find the inverse. But we've got a double log, okay? So this becomes y. Then we switch it. X equals log base 3 of log base 4 of x. Of y. Thank you. Maddie, I think you captured like half my mistakes. Good job. Don't stop. Okay. Can I divide by log? No. This is not log base 3 times log base 4 of y. That is log base 3 of log base 4 of y. So how do I get rid of a log? Convert it to exponential. So this 3 is going to pick up the x. And now that log is gone. Then what? Do it again. So 4 picks up the 3. 4 to the 3 to the x equals y. What happens when you raise a power to a power? You multiply them. So I could rewrite that as 4 to the 3x. And then I make it f negative 1.
So that way you don't even have to plug in x for y. You just get it by doing this. Wait, never mind, you do.
I did. I switched it first. Yeah. Okay, last one. So make that y. X equals 5 to the 2y. How am I going to get at that exponent? I'm going to log both sides, but I want to log what base? Good. Log base 5 of x equals log base 5 of 5 to the 2y. Then what happens? Good. So log base 5 of x equals 2y. Then divide by 2. Be careful. Either the whole log has to go over 2 or I have to multiply by a half. Don't just make the x go over the 2. So either this, f negative 1 of x, either this or this would be right. Don't make that 2 just go under the x. So if it was multiple choice, they'll give you that as an option. Be careful.
You can do the one at the bottom with the 1/2.
Yep, both of them are fine. And again, we're going to eventually talk about how these will be transformations. So you want to understand that that would be a vertical dilation by a factor of a half. Questions? Not bad today, right? Yeah, okay.